Vamos a hablar de la agricultura protegida en las ciudades o urban protected agriculture. So as an urban protected agriculture, there is a kind of extreme environment plant production. This is the same situation to a arid or extraterrestrial cubit farming, for example. Thus are technologies that people use in the urban protected agriculture, the cubit farming, vertical farming, set farming, plant factories with artificial lighting, for example, closet plant production systems, or the simple indoor agriculture. This is the most common or the most advantages of this kind of urban protected agriculture. Somebody have some vertical and suspended grow bags for lettuce, for example, or strawberries, vertical columns, or carnivore driven stake ground system. Also a fine design for medicinal herb, rhizome and broad crops, cable and tray system, which intercanopy lighting for a variety of crops. In the United States and Japan, they have a fully controlled vegetable factories, only using an artificial light with the aim of the gene ground planet production since the 1970s. And in this situation, Japan is now leading in the field of the plant factories. So urban protected agriculture also includes semi-closed systems such as rooftop greenhouses, like this example here this is in Alemania. I think this. So when we are talking about protected agriculture, this is because the urbanization is increasing a lot, and also the population needs new ways of alimentation. So the new agriculture must be delivering fresh local food for cities of 6,000 tons of food imported a day in a big city or a regular city of 10 million of people or citizens. For example, in London, the 40% of the land required should be required to grow its land for the food necessities of the people, and only the 12% of that people live in the city. That's the reason that in world population of 9 billion, we will be 9 billion by 2050, and an half so the 70 to 8% increase in agricultural production will be required. The increase of the challenges, including protect environment, of course, retailing, the distribution, and they need to about the motorized cause pollution. So urban cities needs to import most of the food that they use. So, and at the time that we are using this kind of agriculture, the urban agriculture, we are able to reduce the land surfaces. So urban greenhouses reduce the gas emission of many crops. For example, in the world nowadays, in these days, the 47% of the gas emissions is because the land agriculture. So using the urban agriculture, we can reduce this pollution. And also the fully controlled plant factories also provide sustainable system for the production of medicinal plants and genetically modified crops for the pharmaceutical use. It's very important the urban protected agriculture in that situation. So, of course, the limited space in this kind of agriculture is very important because there is no soil to grow these crops. There is not enough natural light, and they require high levels of control because need to quite resource demanding and technically challenges. It's a challenging every day because this kind of technology is very challenging. However, the advantage are the capacity of optimize the environmental condition. Also, there is another advantage that achieve ideal growth. We obtain the growth that we need. We obtain the maximum yield per area in this kind of production. The ideal we can develop could be multi-layer grow shelves, like you can see in this picture here. They have a multi-layer system that increase the crop uniformity and easy to harvest. They propose yields in an indoor agriculture for times that in the field operation is impossible. For example, the lettuce yields is hundred of times that of field-based system. Is 100 times the lettuce, for example, using the urban protected agriculture. Also, vertical agricultural system produce almost 40 times more crop compared to a typical horizontal hydroponic system. So calculated the ratio of the yield, the fresh match to occupy a growing floor area. So this is important to develop the vertical production. It's very important in the urban protected agriculture. Also, the innovation of the growers are endless. There is a lot of innovation in this situation. And the plants respond to all that innovation in the urban protected agriculture. For example, almost 12 vegetables producing in this situation, like arugula, basil, and oregano in vertical agriculture, they have an excellent plant vigor and growth development. So the productivity and the high quality in this system, for example, the nutrient delivering is very precise. The plant morphology have a response, very good responses, and the nutrition of the crops is very easy to give to the plant the better nutrition that they need to obtain the better development, the best quantity of production, pigments of the plants, glucosolinatos, and mineral situation. So chlorophyll A and chlorophyll B, for example, in brassica is a crop important. They have a better chlorophyll exposed to the LED light of 640 to 440 nanometers. In that exposition of the LED light, they have a positive wavelength and chlorophyll accumulation. For example, in blue light with 476 nanometers of wavelength, they have a higher lettuce leaf tissue, a better B-carotene, and a total xanthophyll carotenoids. So it depends on the light that we apply to the crops. Is a better response of the crop in most of the items that we already call. It's very important, this agricultural protected in the urban or in the cities. So urban agriculture of course, trying to be easy transport and mobility because they are in the middle of the city. So the qubit farming, for example, the container scale plant factory get modular. This is very, very important in the cities. So standardized is easily expandable. They adapt to the climate and the environment. So increasing system optimization, the plant density in vertical farming increase the resources and the energy. For example, they are efficiency in the water use, efficiency in the carbon dioxide, and the like. And the fully controlled versus the conventional greenhouses, for example. They use water range to 0.95 to 0.98 in the vertical agriculture compared to 0.02 to 0.03 in typical greenhouses. Is a better improved use of the water because you apply the water up in the vertical agriculture and they made a very efficient use of the water during all the way the water is across the vertical crops. So this is 30 to 50 efficient use of water and additional situations. The impressive investment and development is being made on the agricultural lighting sector, for example, is most impressive in this area, which has continuous improvement and ever a better efficiencies in the future. Talking about the lights. For example, in the urban control environment, in the vertical agriculture challenge, they have some challenges. They need to develop the technology. For instances, for example, the airflow is very important to make a control and the high density of the crops. So design air and distribution system indoor plant factory now they have a uniform environmental and the airflow patterns to make in vertical control environments. So this kind of plant production system is better with a good flow vertical air, such as the use of perforated air tubes. They are able to provide an average of air velocity of 0.42 meters per second. Other issues such as plant size restriction in vertical plant system are forcing researchers to focus on high productivity varieties of certain crops, for example, such as the micro tomato, name issue cherry with extraterrestrial plant production. The microtina variety is in the field of the extraterrestrial plant production. So we are facing to the future using this kind of technology. So the urban protected agriculture is used to correct the technology. Indoor agriculture have a rapid plant growth, a better plant growth, and they also produce without use of fungicides, herbicides, and pesticides. So the resource efficient and the fuel traceable operation compared to the soil-based agriculture in cost, of course. They have a high pressure. They have high pressure of sodium lamps versus fluorescent lights, and they have a difference of 40% of the cost of the production, and the ventilation in the air circulation, the air quality control is very important. So heating and cooling the greenhouse or the urban protected agriculture They have energy intensive enclosures. For example, 10 kilowatts is like a lot of electrical to produce 1 kilogram of lettuce in a plant factory, for example. And protected agriculture with supplemental light LED are quality and efficiency, for example. Also, the intercanopy lighting, you can see here in the middle of the crops, some LED lights that make a better growing of the plants with intercanopy lighting. They improve the efficiency and detail with regard to resource saving, for example. And amongst the other topics, indoor farming with electrical lighting is very expensive nowadays, but is a very good uh, response to the necessities of the cities. So the urban protected agriculture, of course, is a intensive in technology. Indoor, they have to use the agricultural artificial light, so they are increasing the operation. So, but there are a potential driving force for the development of resource efficient technology to enhance the sustainability of protected agriculture, because they use a lot of light artificial. So urban indoors and warehouses, or they grow from 50 to 56 in 2050 to 2017 in the United States. They are relatively new technology. And in Japan, the number from 35 in December 2009 to increase to 106 factories in December of the same year, for example. They increase in the same year 3 times. So in Asia, they reported over 500 plant factories. And at the end of 2016, there are 3 operation commercial container style farms, with 4 to 5 other in the process of operation. The farm warehouse farms are increasing a lot in cities like in countries like Japan, for example. So finally, because the countries are bilingual climate, South Korea, China, Italy, Holland, Jordan, Saudi Arabia, and Canada, and others are developing a vertical farming. And region offer affordable electricity because they are novel in vertical farming. So alternative energy sources are plentiful, such as geothermal energy, for example, wind, and sun-driven energy sources. They can also offer a competitive advantage wasted to energy in polar regions. They could be in urban vertical farming a good solution. Today, the investments are high, so smaller prototypes to start research consider innovative means for improving energy and efficiency. And as other types of protected agriculture develop alongside urban agriculture, new technology will be available and will be adapted for us by growers in urban centers. So the urban agriculture is growing very, very fast. Very important to be there and to be very related to this